Well, I would like to take this opportunity to welcome everybody to today's webinar. The topic today is actually pretty exciting for us. It's maybe one of the first times we've ever done this. So we're going to just go as fast as we can, but as efficient as possible, okay? My name is Ed Robledo. I'm part of the Autodesk support team and part of the community manager team as well. So we put together these webinars and we schedule and we try to get topics of your interest that mostly you could take advantage of it on your designs. And with us today, we also have Jorge Garcia. Jorge, could you say hi, a little bit of yourself, if you don't mind?
Hi, everyone. It's nice to be with you guys. As you guys know, we've been together for more than 10 years already, Ed and I, and it's always fun. This is a first time we're going to try this 30 tips in 30 minutes, so we hope you enjoy it.
Thank you, Jorge. Appreciate that. So we're going to go ahead and do the Q&A at the end, okay? Because we want to go through the tips. And we're going to go kind of at a rate that is aggressive, but explain enough that way you could take advantage of it at the same time, okay? So, and some of them, there's actually one of the tips, I need to give you a URL. I'll be giving you the URL at the end. I'll put it on the chat. I'll put it for our YouTube friends. I'll put it there as well as our local platform friends. I will go ahead and put it there as well. So just leave your questions for the end if you don't mind. So just make a note of it, of the questions that you want to do. So Jorge, are you ready, you think?
Start that timer. Let's do it.
Let's start the timer. Here we go. Okay, so first of all, this tip is from one of our expert elites, Rachel Peterson. She's one of our expert elites, and she actually generated a ULP in which it will, on the context menu, display the URL and actually link to the URL of a data sheet of your components. What you need to do is that you need to go to the library and actually create an attribute called datasheet. The value of that datasheet is actually going to be the URL for where the datasheet is located. Now, when you're working actually on the board, when you right-click the components on the context menu, you're going to be able to get a link to where it says View Datasheet, as you could see here. When you click on it, it would open up your browser, and you actually have access to the datasheet. The URL that you see on the top of the description is the actual URL that you'll see. Okay, so that's tip number one. Tip number two is in regards of creating components in the EAGLE library editor. As you know, the EAGLE library editor has multiple, it's a platform of multiple editors. One is to create footprints and the other one is to create schematic symbols. When you're creating footprints, you're going to be using through-hole components or you're going to be using surface mount pads. Well, when you activate the command, we actually have an icon on the top toolbar, as you can see on my screenshot here, which is called Pad Array. From here, you could select the pattern of your components. You could determine that you could tell it what distance you're going to use and the naming convention that you're going to be using for the component. It will actually place the components. I have used this many times and I'll do it a single row at a time, okay? And the same command is used for schematic symbols as well, okay? So we're good to go, okay? So, and here it is. And this is how it looks when you're actually creating it for schematic symbols, okay? The next one is actually, and this is a question that comes up really often, Jorge. How do I change the default units in EAGLE? Depending on your operating system, it will actually come up either on it will usually comes up in Imperial system. Now, if you want to force a particular grid unit or a grid size as well, what you're going to be doing is that you're going to go to your home EAGLE folder. There's going to be a subfolder called there scripts. You're going to locate a file called eagle.scr. You're going to edit this file. You could do this for the EAGLE ASCII editor or whatever ASCII editor you have of preference. And what you're going to do is that you're going to locate the section in which you want to use a different unit, and you're going to go ahead and select millimeters, as you could see on my example right here. Okay, so that's how you switch units in EAGLE. Okay. Oh, I forgot I had put some arrows there, George. Sorry about that. To make it easier to locate them. Now, another thing that we always like to determine is command history. There's many commands in EAGLE icons that as you use them, it actually builds a history. You're going to notice on the icon here, there's like a little sliver there with a little down arrow. That means that that command actually builds a history. If you click on that arrow, on that little sliver, that little arrow, it will actually drop down all of the commands or all of the options for that command that have been used. I particularly use it a lot in libraries. So instead of having to go to the add command and go all the way back to the library menu, I just click on there. That way I could get the most commonly used components that I use. Is that about right, Jorge?
That is about right. It also works on the script and UOP commands as well. They also build histories.
That is absolutely correct. Okay. The design manager. This is actually a really good one. The design manager provides you calling commands. This is in this here. What we want to tell you is that you could call out commands from the design manager according to what you have selected. In this example that I have here is on the design manager, I have selected a signal that has not been routed. When I right click on that signal, as you could see, I get the options to either quick route, or I could do a fan out for that signal that I've selected. Or if it was actually a trace, because part of it is actually routed, I could actually rip up the entire trace as well. Okay, so instead of having to find the actual command or the icon, you could take advantage of the design manager to execute certain commands that are commonly used on the design. Now remember that the design screens, these sub screens, you could actually put them on a different monitor. That way you have more workspace. Okay, well, right, George? Excellent. Now, this happens quite often. You'll be manually placing vias. Either they're going to be test points, or they're just going to be able to join a polygon from a layer to another layer. It's quite possible. You may have ground layers on the bottom, ground layers on the top, and you wish to join them at certain points, and you place vias manually. Now, when you're placing vias, if you use the command line and put in the name of that via between single quotes, that name will be adopted by that via that you're actually placing. In this example, the via is actually attached to my mouse cursor still. Then I put single quote, the name I want the via to have, close single quote, and I hit enter. The reason I need to use single quotes, if not, it's going to try to interpret the value that I'm using as the diameter for the via. Okay, in this case, we don't want to use a diameter. We're actually assigning it a signal. Excellent. The next one is that if you are manually routing, using a lot of the command line, if you're manually routing and you wish to change the width of the trace that you're routing, just go up to the command line and type in the value you wish to use. In this case, I'm actually routing a trace, and I go to the command line and I type in 0.116 millimeters, and that way my trace width changes to 16 millimeters. I don't have to go to the drop down menu or anything like that. Just type in the value that you want, hit enter, and that trace width will automatically change.
Yeah, and keeping in line with that, most of the time, if the command line is enabled, you can just start typing. You don't actually have to move the mouse up, so it can save even more time.
Correct. Keeping straight lines, and this is one of my favorite. This is kind of a favorite one by Jorge, I would say. What happens is that in this GIF file, if you already seen the GIF file, you'll see that when you're manually routing a trace, it will actually bend really easy. I guess it's called ortho. It will actually bend really easily. But sometimes if you're using a really fine grid, that's a disadvantage because it just takes the bends too easily. Now, if you want to keep the trace as straight as possible, what you do is that you're gonna press and hold the control button. That is gonna kind of force the trace to take a lot more effort for the bend to apply. Is that about right, Jorge? Did I say that right? You want to describe that?
Yeah, so the way it works is basically, depending on your bend style, like here we have a 45 bend style. So once you're closer to the 45 degree than the straight, then it's going to jump. But it allows you to make long straight traces really easily, even on a fine grid, because you don't have to worry about tracking the line so perfectly.
And this is like if you're working like on a really, really big grid, a small grid, I should say, is where you're going to take advantage of this. Now, single layer view. We use this one a lot. If you have maybe most applicable if you have more than 4 layers or more, this provides you the capability of only seeing the active layer. If you're doing a manual route and you have this option enabled, every time you switch layers, that layer is going to be the active layer, and all the other layers will go kind of grayed out a little bit. As you could see on my little screenshot here, I'm actually working on the bottom layer. Therefore, that layer is active, and all the other 3 layers are actually grayed out, so they kind of like fade out to the background. This makes it a lot easier for when you're routing. You want to describe this one really quick, Jorge, about avoiding the context menu by creating a group?
Yeah, so when you form the selection, what happens a lot of times is we'll right click and then select the option they want to perform. But if you form the selection first, you select the command you want to perform and just control right click, you can avoid using the context menu altogether. So in this case, there's still a little bit of context menu, but not too much. But often what will happen is users will see the entire context menu and have to scroll up and down. So if you just make your selection, pick the command, and then control right click, or if you're on a Mac, command right click, then you'll see that you can just immediately apply the action to the selection and you don't have to go through the context menu. And that tends to save a lot of time. And it's one of the quickest ways to become efficient with Eagle.
Absolutely. Thanks, George. Appreciate that, man. Yeah, it's a little different sometimes. Jorge's on a Windows and I'm on a Mac, so sometimes it just goes off a tad. Now, net classes is the capability of providing in your schematic or on the board. It gives you the capability of assigning a particular wire width, a particular clearance, and a particular drill size for the vias that is going to be used for those. What you do is that you click on the edit pull-down menu and select net classes. At that point, what you're going to do is that you're going to define your net class. Once you define your net class, you're going to tell it which signals are going to belong to that net class. Once you've assigned it what signals are going to belong to that net class, then you could go to the Rules tab, and there you could select what clearance you're going to use, what width they're going to use, and what drill size you're going to be using for it. Once you've done that, you could actually go to the properties of the nets in your schematic and assign it that net class. The beauty of this is that it's actually obeyed by the auto router if you are going to be using the auto router. Attributes. Attributes is a simple key value pair that allows you to embed design easily into your designs. Happens is that in the device, well, actually we commonly use on the device, you could create an attribute, give it a name to that attribute, and give it a value. The nice thing of the attributes, it actually becomes part of your bill of material. In this example here, I have a device in which actually has the manufacturer part number, and one of the distributors that has it available that includes their kind of stock number when you're going to order them. And all this information will be part of your bill of material. Did I miss any part here, George?
Well, I just wanted to add that you can also define attributes at the schematic and board level as well. And basically, their power lies in their flexibility. You can use them to store any type of data that you want. In this example, we've used it to store ordering data, but really you can use it for anything, such as author, check date, anything like that can be stored as an attribute.
Excellent. Thank you, George. Appreciate that. The next tip we want to talk about is about meanders. The meanders could be applied to differential pair routes or to single lines. The meander command, what it does is that it provides you the capability of being able to define a particular length for a line for line matching. Should that be right, Jorge?
Yeah, for length matching. So a key part of using the meanders is that where you start on the trace segment is important. You want to generally start from one end of the trace and then move towards the other, because as you can see, that gives you the most distance to add coils in. If you start in the middle of the trace, you're only going to be able to add coils from the middle to the end, to one end, or from the middle to the other end. So it limits the distance you have to be able to add the length matching coils. So,
And then remember that the right mouse click actually provides you the capability of in which section is the meander going to actually appear. Okay. Fan out. I'm a kind of a fan of the fan out. I usually, in this example on the GIF file, I'm using it for the entire component, but usually you'll be using it for a particular signal. You have the capability of assigning a component or a signal name. What it does is that it actually will break out um, the signal from a component or a signal name throughout the entire design. We just route it out a few mils and put a via that and place that via, and that via is going to have the same name of the signal. Therefore, if you have polygons with the same name, it will connect to the polygon, especially if the polygon is on a different layer. Common use example would be you have a polygon called ground on layer 2. You fan out all of your grounds on your board, which will go to a via and will connect to them. And that way you could get them out of the way. And electronically, it actually there's an advantage to that as well. Okay. So you just wanted to be able to show you a little bit about that fan out tool that is located. There's different parameters for the fan out, which you'll be able to experience. Jorge, can you go over schematic simulation real quick?
Yeah, so you want to take the time to learn how to work with the simulation in Eagle, the simulation engine. Oftentimes, people have given simulation a bad rap, just in that maybe it doesn't behave the way they're expecting, or they expect everything to work, perfectly right off the bat. Simulation is something that is very dependent on the quality of the models given, and it's worth putting in the effort to learn it. You can save a lot of time on your production runs by testing ideas out before committing to hardware. You can explore different options without ever spending a dime. So it is worthwhile to take the time to learn simulation and use it in your projects.
Thank you, Jorge. Appreciate that. That's awesome. Yeah, simulation is a great tool. Just got to spend a little time there learning it. DRC, you want to go over this one really quick, Jorge, please?
For sure. So one thing that's really handy is if early on in your design process you know who's going to be making your boards because you've used them before, or it's a board house you like to work with, then just as early as possible in the layout, set up your DRC to match their requirements. A lot of board houses provide Eagle DRU files. You can just download them and use them. If not, take the time to set up the DRC to match them, because the default DRC is set up to be very conservative so that any manufacturer can have success. But that can also lead on more complex design, can lead to bogus errors. So just set up the DRC to match your board house. That way you know that any errors Eagle flags would be the same ones that your manufacturer would flag.
Yeah, and I reiterate, just to let you know that most common board, a lot of times board houses have the DRU file. This is the design rule file for Eagle, which you could go ahead and load as well. Okay. Now, Um, this is actually a pretty neat one. And this is kind of well hidden, I would dare to say. It's not very well told about, but if you have a straight net in your schematic that is connecting from point A to point B, if you place a component anywhere within the path of that net, Eagle will automatically create the connection for you. So it'll split it. The nice thing is that both ends will have different net names. So you don't have to worry about the net name being the same. So it's not shorting it out, okay? So it actually splits it. So it actually, as you can see in my little GIF file that I have here, it actually splits the line. That way the signal on the top has a different name as that signal that it's on the bottom, okay? So it just makes design time a lot easier. You don't have to go ahead and split it using the split command, or the slice command, I should say, or delete it and have to rerun it again. Okay, it just automatically will connect. Teardropping. Teardropping is a ULP that Eagle actually has for a little while now. And what it does is that it creates a teardrop effect in the direction of the trace, as you could see here. So when you Gerber that, you'll get that thicker trace. And this is actually quite commonly used on designs that are going to be in extreme conditions. That way you get that additional connectivity to the actual trace. Did I miss anything there, Jorge?
Yeah, just the key point when using this tool is to make sure you run it at the end. It's a little bit hard to undo. So just once you're done routing, save the board, then run it. If you need to change anything, just close the board and open it again. Yeah, going back to what Ed was mentioning, the key point is it gives mechanical stability or mechanical rigidity to the connection. So if it's in a high vibration environment, it's more likely to survive.
Now, just to let you know, this is actually a ULP, and to execute it, you can actually go to the ULP icon, which is on the top toolbar, and select the teardrop ULP from the list of ULPs that are available. The selection filter. Jorge, could you go over this one really quick?
Yes, so selection filter is new. It helps make it easy to form your selections. Basically, you can choose what types of items can be in your selection. And you can do it on a layer by layer basis. So if you only want to select the top devices, forming that selection before would be very difficult, because you might have to form a complex polygon, or you might have to make a big group and then cut out certain things. But using the selection filter, it makes it very easy to form the selection with only the items you want. So we encourage you to take advantage of this feature.
Excellent. Thank you, Jorge. Appreciate that. Object Inspector. I'll let Jorge go ahead and keep on a roll on these.
So in the case of Object Inspector, one of its key properties, as you notice, this is the first tip on Object Inspector, we'll be talking about it again, is that whenever you form a selection, what it's going to do is it's going to allow you to modify any properties they have in common. So in this case, I have these 3 resistors. They all have that 10K value in common. So I can change it to something else. If I need to position them in a certain way, for example, I want them all at the same height, I can make that change, and that value would be assigned to all of them. So it's a very powerful feature, especially when making changes to selections of items.
You could actually even change the footprint, or you could rotate them, or you could align them, which is really nice capability.
You're messing with tip number 2, man. What's
No,
up with
I'm
that?
sorry. Go ahead, go.
So as you can see here, the key point that we want to note is that the Object Inspector is aware of the items in your selection. So the Quick Actions dialog at the bottom will adjust depending on what's in your selection. So if you notice in the first picture, we have a selection that has devices, has vias, has traces. The only action that can really be performed in common to all of that would be a delete. Hence, that's why that's the only option there. But in the second image, you see that we have a selection that consists purely of devices. So now we have other options. We can delete, we can rotate, we can mirror, we can do the different aligns, we can replace. So it's just to show that the Object Inspector is aware of what you're selecting and will adjust accordingly.
Excellent. Thank you, Jorge. Appreciate that. It's a very useful tool. I strongly advise that once you start getting used to it, you're going to be using it all over the place. Especially if you're bored, you have really dense boards. Now, filter was a new feature that was just recently added in this new version. I'll let Jorge go over this one as well.
Yeah, so filters are very powerful. They're actually a big infrastructure move for Eagle, and we're going to really be leveraging them a lot as Eagle continues to develop. But initially, one of their big strengths is that they allow you to make a very specific selection, regardless of where components are on your design. So as you can see in this example, I've searched for devices whose name starts with an R, and whose value is equal to 10K. So I'm basically looking for all the resistors in my design that have a value of 10K. And then once you get the list, you can actually highlight whatever items you want to modify and form a selection. So it's a very powerful feature, because as I continue to add resistors, this same filter can continue to work. If I add 2 more 10Ks and I call this again, it's going to add to the list, so it can dynamically update.
The beauty of it is that you could save it that way. You could use it in different designs as well.
That's my other filter tip.
Oh, I'm sorry, George. I keep on jumping the gun. Go ahead, George. Sorry about that.
So yeah, so as we were mentioning, you can actually save the filters for using them later. So you'll notice that you have the option to save them in the design, so they become local to the design. Or if it's a filter you think you're going to be using constantly, you can actually save it globally, so it'll be available to all your designs. And this one that I've highlighted here is actually a very powerful filter, because it can help you detect what components are missing splice models. You can also make a filter that searches for components that are missing your 3D model. So before it was very difficult to remember which ones maybe were missing in your design. Now the filter will let you know what components still need models assigned. So it's a really good time saver that way.
Polygon Eyes gives you the capability of being able to take any shape that has been drawn and it's totally enclosed, and allows you to actually define a polygon. That way it gets filled in. This is commonly used for DXF files. When you're importing DXF files in Eagle, they will always come in as a closed contour shaped. And there are instances in which you actually want that to be filled in for X or Y reason. Therefore, you could just right click that shape, select the option Polygon Eyes from the context menu. You could either create that one into a polygon, or you just tell it to copy, and it's going to prompt you to which layer you wish to copy it, and then you could turn that into a polygon and assign it a signal name. This makes it a lot easier for you to create polygons on actually defined shapes that you have on the board. It's not subject to only layers on copper layers. You could actually do them for other layers if necessary as well, the non-copper layers. When you're creating a component in Eagle, either a footprint or either a symbol, there are always two attributes you should always add, and that's for the reference designator and the component value of it. There is a ULP that is called set underscore name underscore value dot ULP, that you could run. And what it does is that it looks at the shape of your component that you've created, and it will actually put those attributes there for you. That way, when you're using this component in the schematic on the board, the attributes are there already for you. The assign command, which is it's under the options menu, okay? Um, allows you to actually common commands that you do. It doesn't have to be a single command. It could actually be a script, like a command line, like a whole script. Let's say it could be a move with multiple alternatives, and you could assign that entire script to a command, to a keyboard stroke. Here I'm using a modifier like Alt 1, so it sets my via pattern and so forth. So it allows you to take commands or command strings and assign it to a shortcut on your keyboard.
Yeah, and we also want to note that the assign command isn't strictly limited to the options menu. You can actually use the assign command in the eagle.scr, and that allows you to make the shortcuts you define more portable. So you have that option as well.
Excellent. Thank you, Jorge. I appreciate that. Also, here we just wanted to let people know about the actual command line that Eagle has. You want to tell them a little bit about that, George? I use it a lot, actually.
Yeah, so for many of maybe a younger generation, myself included, the command line is something that isn't very commonly seen, but it allows you to very quickly form precise selections as well. You can also form precise movements. You can say move to this specific location. We get a lot done through the command line in Eagle, as you guys have seen through some of the other tips. There's a lot of power embedded in it. So it does pay to become familiar with it, to be able to quickly perform an operation, or be able, like we saw, increase trace widths or name your vias. All of that saves you time. So even if it seems maybe like very 80s, it is a very powerful feature and something that is worth getting to know.
Absolutely. It could save you a lot of time. And so the most common work scenario is you have your right hand on your mouse and you have your left hand on the keyboard, and you kind of like work in combination of. Now, there will be instances in which Eagle includes, I don't know, like 300 to 400 libraries, and you don't always need to be using those libraries. Within the design editor, like the workspace of schematic board, there's a way of actually putting them in use or not in use. In other words, do I want to see them? But it's a lot easier if you actually do this management directly through the control panel. What you do is that you expand the library tree from the control panel, and next to the name of each library, you're going to see a dot. If the dot is green, it means that when you click on the add command, that library will show up. If the dot is gray, it means that that library doesn't show up. In this example that you see here where it says manage libraries, if I go up on top here and I was to just right click it, you could actually select the option to use none. In other words, none of the libraries will be selected. Then you could go back and just select the libraries that you actually want to use in your design. Okay, excellent. The next tip we want to talk about, and I kind of made this GIF, is I just find it really useful, is by creating a bus. You see, before you actually would have to draw a bus and use the name command and give it the properties of that bus, of what signals it was going to be conducting. Now I'm actually able to just define a group and select all of the nets that I actually want to create a bus, and I could right click one of the nets and select the option create bus. Now I could draw that bus, and you'll see that I get all the names of those nets inside the property of that bus that I just created. So in other words, I could create a bus in like 2 mouse clicks, in which before you would actually have to type a lot of commands once the bus was actually done. This is a great time saver, especially if you want to use this bus on a different sheet. In this example, I'm not using a different sheet because I just wanted to show you that the signal names actually transfer to it. But it's very common use scenario would be actually once I create the bus, I open up another sheet or navigate to the sheet where I actually needed to transfer those signals to another sheet. The split command. You want to go ahead and explain this one a tad, Jorge?
Yeah, so the split command is a command that many users aren't usually aware of, but its big strength is the fact that it'll add vertices to the closed contour, so you can use it on traces or on a polygon. And its big advantage is that it keeps the contour closed. So if you were to try to modify the outline using other methods, you would have to delete an existing segment, then draw the new segments and close the contour again. But using the split command, you'll see that the contour is preserved the whole time. So it can save you a lot of effort. When you use it on existing traces, it's handy because, as you guys know, Eagle will try to optimize segments. So if you have collinear segments, they'll be turned into one, which won't allow you to modify the breakpoint any longer. So using split allows you to introduce a new breakpoint or a new vertex.
Excellent. Thank you, Jorge. Well, I just have special mentions for 2 tips that I actually wanted to bring up, but we did not put them because we've already done all 30 that we actually wanted to do for this webinar. But some special mention would be persistent groups. That's a really nice tip. That's a really nice command that is recently added. Also, the fact that now you could share your libraries via Hub. So you could actually share libraries that you have created through managed folders of your managed libraries. And that kind of covers all of the tips that we wanted to do for this one session. Okay, so in essence, our webinar is over. Now we're going to go ahead and open up the floor to take some questions and Q&A and be part of the chat. Everybody, thank you for joining us, and let's go ahead and answer some questions. All right, let me see what we have on Q&A.
If anybody's interested, I timed this 30 minutes, 17 seconds.
Nice.
We done good.
We did well. So I have one. It says here, could you please show how to match total length of a differential pair and 2 or more different wires for phase matching? You know, we actually do a webinar based on that. I'll go ahead and cover those on our next webinar, okay? If not, I'll create a tutorial. There is actually a tutorial already on it on our YouTube page, but we'll go ahead and make another one in which we'll cover that, okay?
Yeah, so just to finish off that question, the length matching, assuming again that the drivers, the original circuit, they're in phase. If you match lengths, then the phases should match as well. Again, as long as there's no changes in impedance and they're identical, the traces are identical. So like I mentioned, we'll go over that in another webinar. But in most situations, if you length match, you'll phase match as well. Only if you do changes in width and alter the impedance of the traces will there be a difference there.
Thank you, Jorge. Appreciate that. Another question that we have is about the miter function. Basically, what the miter function does is that it takes any corner and it chamfers it. Either chamfers it in a curve angle or it chamfers it in a 45-degree style angle.
Yeah, if anybody uses Fusion, miter is basically fillet. The same command in the Fusion sketch space is basically a fillet. The only thing miter does extra is that you can turn a 90 into a 45, so it'll cut the corner off, with a 45-degree line and put in a 45-degree trace. So that's what miter does. Basically, if you're familiar with Fusion, it's the fillet command for Eagle.
Excellent. Thank you, George. Appreciate that. I was trying to bring one up really quick to see if I could bring up a really quick design. That way I could show it to you. But if there's any other questions, let's go ahead and send those while I get together here. Okay, I'll go ahead and let me load a really quick board really quick. Especially, yeah, exactly. He's a professional. He never uses 90 degrees, but it still applies, though. Don't get me wrong. It still does work. So I'll go ahead and use the miter command here. And you have two options here, either curved or straight. I'll use curved here. And if you go to one of the corners, you see it turns into a curve angle instead of the actual angle. So we went from this shape that you have here to this shape that we have here. If I wanted to keep the actual shape, a straight miter, I could use this selection here and just do it like that. Okay. So in essence, that's what the miter command does. Hopefully that helps out. Let me see if I have anything on our YouTube page. Oh, hi, Cynthia. Oh, she made it. Ah, she made it a little late. Sorry about that, Cynthia. Don't worry about it. We got the recording. We'll be posting that really soon. So we're good. I don't see any other questions. ¿Dónde? No.
So you can, when you go into the design manager, the filter, go into the design manager filter, Ed. Finger filter. Make some room. Okay, object type, make sure it's equal to wire. No, object type is, leave object type alone.
Oh, okay, here.
And then there, make sure it's wire.
A line, right?
Does he want lines or wires? What do you say?
Wire. He said wires.
Wires. Yep. Okay, click wire, then click the plus sign. Now under the name option there, Ed.
Oops.
Whoops.
Sorry about that.
Okay, click on the name. Let's see if there's anything that says
angle.
It doesn't say angle. What would be a good way? See if there's another way we could do it. Yeah, I don't see a nice way to do angle because we can't filter based on curve. If we could filter based on curve, that would work.
Yeah.
So no, it looks like we don't have a way to do angle unless we could do it as some combination of length and XY type situation. That would be the only way I could see us doing it.
Yeah, we would have to try that one now. So the answer, I guess the official answer would be no.
Would be no, but you may be able to hack it.
But there might be a way of doing a combination of the different filters and being able to actually make it. But right now, I don't see a way of actually doing it by angle. It's actually a pretty interesting idea, though.
Yep.
It's actually a good idea. We'll make a note of that one.
Actually, if she wants the angle, the DRC has a check for it. You can check for off 45s or off 90s.
Oh, okay.
If you go into the DRC, the miscellaneous tab, there's a couple of check boxes that are off by default. And you'll see that there's something that says check angle, yeah. So if you have any deviation, it'll catch it.
But it's not part of the filters just yet.
No, it's not part of filters.
Okay.
We have a question. Simon thinks it would be handy if we had a wizard to create IPC footprints. Well, Simon, we have good news for you. If you go into the library editor and you go to the 3D package column, there's our IPC Wizard for making footprints.
Yeah, it's actually pretty nice to use. Let me see if I could bring it up really quick. It's based on like templates. So let me bring up a library really quick to see if I can.
Just make a new one. Just make a new one and you can show it.
I'll just use this really quick. So let's say, for example, I create a brand new footprint. No. Yep. Add a footprint.
Nope, not footprint. 3D package.
There you go.
Create with package generator.
It's right here, the option. You see it down here on the bottom, create package generator. And here comes up the IPC. It actually has all of the IPC components plus some. So you'll see we have your regular axial components. In addition, you have your crystals and so forth. In essence, what you do is that you select one of the cookie cutters, type in the values that are necessary for the component, depending on the manufacturer specification sheet that you may have. And you could click on Update Review. It not only it will actually create the footprint, it will actually create the 3D model as well.
Yep.
Just to let you know, it's actually really easy.
So
really easy to use.
We also have a question from Ricardo: how to change pad size on a board without changing library? Not possible, and for good reason. Let me actually rephrase that. Technically, it is possible if you mess with the with the annular ring settings, but that will just change the overall diameter of the pad or via. But in general, you don't want to be able to make a change on the board without having to go through a library first. And the reason for this, and it's a key principle of EAGLE, is the library is your source of truth. So let's say, for example, you have a board and you put in a component and you make changes to the pad sizes, and then you have that board manufactured and everything is okay. Well, if you were to ever to use that library again for a new design and you didn't remember that you made that change, guess what? Now on this new design with the wrong part, because you changed the pads, the board wouldn't work. So by making sure that everything in the library is correct, you guarantee consistency between designs. So you can't change the pad size on a board, and we don't foresee ever doing that because there's a lot of danger associated with that possibility.
So a quick explanation is that the annular ring value that you see here basically will calculate your pad diameter based on the drill hole size being used by the pad. But the value that the resulting pad diameter is going to apply to all of your pads. It's not going to apply to a particular component. Now, recently I had a case in which the user wanted to know the specifications of the component pad sizes itself. He wanted to query it. You could actually use the design manager. You select the component in question and just go down to the bottom of the component, and it will show you the exact sizes for that component. Okay.
Got any YouTube questions?
Yeah, I think I got one here. So are rounded corners available as library as an option on EAGLE? Are rounded corners available as library or as an option on EAGLE? Not really sure exactly what you're asking there.
Are you saying for the pads, for the SMD pads?
Hello there.
Is that what he's saying, or she's saying?
Hello there. How see the pad rounded corner? Well, when it comes to SMD pads, we do have the capability of having rounded corners. Yeah, and that's actually done by a percentage. So yeah, you can have surface mounted pads by rounded corners. Okay, so yeah, for SMDs we do have that. Any plans for a textbook describing the contemporary EAGLE commands? How to find tips, hints like those and described today? I know they're working on some literature, but I wouldn't be able to describe it directly like that. Jorge and myself will continue making more of this available through our YouTube channels and through the website as we continue going along. But yeah, I'm sure there is more being planned by the Autodesk team as well. Then Sagar has a question about EAGLE Fusion 360 question. Is it possible to create custom silk screens in Fusion 360 and bring on them to EAGLE? No, that's not possible. No, because it's treated as a canvas, and that doesn't reverse over to EAGLE. So no, it's not possible. No, not yet. It would be good if we have two locking options. 1, X-axis lock, and 2, Y-axis lock. It would help in maintaining axis consistency while moving devices, or it can be given in the move command. Hmm. I'm wondering, are you talking about components? Because we do have a locking mechanism. Oh, I understand what he means. So like in Fusion, when you move apart, you can make it
It'll stay
X or Y or freehand. Or freehand. Yeah, that's actually a really good question. That's a really good idea, Summit. And I have a feeling that that will actually be implemented at some point. Because Fusion has it and it works really well. I use it quite often. So that sounds about right.
If not, in the meantime, you can use the align functions to fix it after the fact. So you can place them kind of in the more or less where you need them to be, and then you can use the align functionality to line them up perfectly.
Yeah, remember that you could always create a selection for multiple elements and use the align command. That way you could actually align it if necessary. It makes it a lot easier.
Even Inspector could do it. Inspector could do it also.
You could do that in Inspector as well. And the design manager, yeah, exactly.
Inspector, yeah.
Mm-hmm. You know, the align command should have been one of our tips. Well, next, we got to leave some stuff for the next one.
We got 30, man. 30 and 30.
Excellent. Let me see. What else do we have? I don't see anything else anywhere. I haven't had the chat on.
Make sure YouTube, because here on Zoom we're good. We're covered on Zoom. Make sure YouTube isn't missing anything. Scroll up the comments.
Yeah, someone is just making the comment that he uses the align command a lot because of that.
Yeah.
When he's doing it. Yeah. So yeah, it's a really good idea. Well, I think we've covered all the questions. Thank everybody for joining us, Jorge. Fantastic job. Greatly appreciate it. We pulled it off in 30 minutes, so we were not sure if we were going to be able to do it. We didn't want to make it a 2-hour webinar. So I think we actually gave you some really good content to optimize your design time. Our producer will have everything available for you. Hopefully she could get it done by the end of this week or by sometime next week. So we should have it up and running for everybody to review it and have it available to you.
Remember, you had a link you wanted to post.
Oh, let me post this link really quick. Hang on, give me a second. Let me go get it. I have to. I gotta stop sharing my screen for a minute.
Do it.
I'll be right back with that link for our YouTube friends really quick. Give me a second.
If Rachel was here, she could post it herself.
Yeah.
But I don't think she's in.
Yeah, I got to get Rachel here. And I had it, and for some reason, I closed that screen. So let me go get that link really quick.
If worst case, just go to our forums and bug Rachel, and she'll post it.
Mm-hmm.
Or we'll ask her to post it. Worst case.
Okay, so I'm gonna post it here for our platform. You'll notice it's an Element 14 screen link. That's where she put that blog. There's actually, she explains many ULPs there that she has created, but I just feel that one is actually a really, really useful. And I'll go ahead. Let me see if I could post it here for our friends on YouTube. Okay, yep, there it is. I was able to post it on both platforms. So you'll see that it's on our YouTube as well as on our Zoom platform as well. Okay, so there you go. So my first tip was about being able to create a link to data sheets. Go to that link that I just provided you, and it explains exactly how to set it up. It's actually really easy to set it up. Everybody, again, thank you very much for participating and being part of today's webinar. I think it worked out really well, and I think we have one coming up early next week. Have a great day, and thanks for being here.
Bye, everyone.